I'd like to call this meeting to order. Ms. Huerta, would you please call the roll?
Mayor Paulette Oaxaca.
Present.
Council members Roland Barrera,
Here.
Gil Hernandez,
Here.
Michael Hunter, Billy Lerma,
Here.
John Martinez,
Here.
Ben Molina,
Present.
Mike Pesley, Greg Smith,
Here.
City Manager Peter Zanoni,
Present.
City Attorney Miles Risley.
Here.
Mayor and Council, a quorum of the council and the required charter officers are present to conduct the meeting.
Great. Good afternoon, Mr. Murphy. So we will have the briefing
Yes,
from
ma'am.
yourself, correct?
Yes, ma'am. You ready?
Yes, sir.
Okay. Well, thank you, Mayor, Council. It's good to be here today, and ending my first 8 weeks with the City of Corpus has been an amazing 8 weeks. I can't believe how fast it's flown by. But a lot of that, the reason for that is because of all the work that we've put in on this desal effort and getting to know the process and getting to know the history and the background and the decisions that were made in the past that actually got us to where we are today, which is what we're going to talk about. But before we do that, I want to introduce our internal team. Now, a lot of these individuals you probably know. There may be one or two that you haven't met. So I'm going to just quickly, if it's all right with council, just introduce our desal team right quick. We've got Kevin Norton. You all know Kevin. He's the Director of Water Utilities. We've got Gabe Ramirez. Gabe, everybody knows Gabe. He's manages our water treatment effort, water quality. Daniel Dang, you know Daniel? Daniel started on this committee when he worked in engineering. And so I brought Daniel on because of his history and background, and then also because of his education on a lot of the things that we're going to be discussing today. And then we've got Esteban Ramos, Steve Ramos. Everybody knows him. He's probably, I guess, the most diversified person on the committee that knows more about what the water issues are, water resources needs are. And so I've invited Esteban to stay on the committee. And then Amber Odding. Amber is our strategic communications manager, and I cannot thank Amber enough. She is the one that has put up with this committee and tried to make sense of a lot of the stuff that we were kicking around and a lot of the ideas that I brought to the table and put them into a packet that actually made sense. And this, she put together, her and her team, there's Shelby and Aaron over here that helped put the presentation on for today. And so a lot of thanks goes to them, and because they spent a lot of time trying to make sense of everything that we are working on here today. And then Maria Corona. Maria is an environmental engineer. She graduated at Texas A&M Kingsville, and so she gets the privilege of talking about the really wonky engineering kind of stuff with council today. And so at times she may be reading from her notes, but she knows this information frontwards and backwards, and so she's going to be presenting a lot of the information that is in the environmental information that I gave to council last night. And I promise you I did not mean that was for homework for this meeting today, because we are going to go through that in great detail of what that means. And so last night was a really big night. Did I leave anybody out? I don't think I did. Last night was a really big night for the desal project moving forward, because we finished, when I say we, and I've got Jason Conklin with Friesen Nichols. He is online. He's actually at a conference in Florida looking at studying membrane technology in a conference in Florida, which is appropriate because of what we're going to be talking about today. So he's online to answer any questions that may come up for him also. But I think it's appropriate that we take a look at everything that brought us to this point where we are today in this process. And so I'm going to just kind of lay that out quickly, and then each one of the individuals that I've introduced will have a speaking role at some point or sometime during this process. But this is meant to be a discussion. This is not meant to be a lecture from me, because the last thing you want is a little engineer from Texas Tech lecturing you guys on things that you probably know much better than most people in the country. But just so you know, congratulations, I think, is the first thing to talk about, because this is a competition. The competition to be really the first one on the Gulf Coast to do a desal project of this size and magnitude. And so I think it's an honor that we were selected, and I'm going to say we because I feel like I'm part of this family and team now, selected to do this project. This is a critically important project. And speaking from an engineering perspective, is absolutely a project of a lifetime to be able to work on. So I could not be more happy about that. But as you saw when you walked into the room today, you saw up on the message boards we had drought proof, and that's a critical piece of what we're talking about today. The drought of record that we're using to get into the desal project was a 2011 drought, and probably I'm the only one in this room that probably was not here. Maybe Amber wasn't here in 2011. But you all know what I'm talking about. So the worst thing you could possibly do, I do know this, being from West Texas, the worst thing you could possibly do is try to figure out where you're going to get water during the middle of a drought. That is the worst thing you could possibly do because it's almost next to impossible. Many people have tried it. Many people in the past few years have tried it, and it's definitely expensive, and it's not the best way to go. So thank goodness for the foresight of those who came before you, put this process in place to start looking at a drought-proof source of water to diversify the water portfolio that the city of Corpus has. Our portfolio right now is river water and lake water, and it's all dependent on rainfall. Everything that we get is dependent on rainfall. So as we went into this process, council had staff look at surface water, additional surface water supplies, groundwater supply, aquifer storage, and water reuse. All those things were looked at, but desal kind of kept coming to the forefront as the best way to move forward with a drought-proof, not rainwater required source of water, and adding that to our already existing water utility portfolio. I agree with that assumption that that's the best way to go. So how did we get to where we are today? Back in 2019, and we'll get started on this quickly, council made the decision to move forward with two particular sites, the Inner Harbor site and the La Quinta site. And I think many of you were on council at that time. Some of you are new members that weren't on council at that site, but two sites were selected. And that's what initiated staff to begin this process of developing a strategy on what it would take to build a desal plant at one of these two locations, the Inner Harbor site and the La Quinta site. And I believe in that particular council meeting, Inner Harbor was selected to go as phase one. And I don't want this to be a competition between one side or the other. What this is we're just trying to determine, because that conversation has already been had. Now, if council wants us to pivot from that and go a different direction, that's obviously within your purview that you can do. But based on the information and the direction that staff was given, we're looking at these two sites. And so Inner Harbor was selected as phase one. The La Quinta site is phase two, not one against the other, one opposed to the other. So we're going to go into great detail this afternoon and talk about the pros and cons of one site versus the other, not on which is the best site, but which is the more appropriate site to be selected as the phase one site. Now, like I said, this is all under your purview. No assumptions have been made that this is absolutely the way we're going to go. All we're trying to do is move this project forward. Because when I got here, one of the first things that Peter had me do was attend the council retreat about 6 weeks ago when we had the council retreat. And a lot of the things that I heard at the council retreat, and we'll go over those in just a minute, were basically that the project was stuck. It was stalled. We need to move forward. We need to move this process forward. So we're going to be talking about that. But first, before we get any further into the conversation, I'm going to bring Kevin Norton up here because he took the lead role in, I guess, the committee that was selected to come up with and evaluate several different sites. And we started out, I think, with 21. I'm not going to steal your thunder, Kevin. So come up. We're going to talk about how we got from 21 to the two sites that we're talking about today. And then we'll get a little bit deeper into this. So Kevin, if you'll come up, we'll talk about that and we'll talk about other things.
All right, thank you, sir. Good afternoon, Mayor and Council. So this is This is just a refresher from the April 26, 2021 workshop about the desal plant site selection approach. And representatives from Port Industries, the PIC, San Patricio Municipal Water District, the Port of Corpus Christi Authority, and the city were involved with this the site selection process. And after that April 2021 workshop, I actually learned that in addition to the other potential alternative water sources that the COO was talking about, that the original idea here, 8-9 years ago from the group was to have one large plant. And but then as they were looking at that, they decided that, you really have to kind of build it for the requirements. It's going to be very, very cost prohibitive doing that and just kind of sticking it in the middle. So it's better to do a phased approach, having one on this, they refer to as kind of the south side and the north side, with the north side being San Patricio County. So those representatives from the PIC, San Pat Municipal Water District, Port of Corpus Christi, and the city identified and evaluated 21 potential sites, like the CEO mentioned, and then they eventually narrowed that down to the 2 best sites. And with this slide here, if you could imagine balancing a 3-legged stool where the 3 legs, that slide there. If you could imagine balancing a 3-legged stool where the 3 legs represent sustainability, economics, and environment. Sustainability spoken here is primarily in regards to the raw water supply, and seawater, of course, is a sustainable raw water supply compared with our current surface supplies. So the focus or the goal of the committee that was looking doing the site selection was to balance the economics and the environment aspects. So what we see listed here are the site selection factors and the phase process to reduce the 21 potential sites down to 4 candidate sites, and then ultimately to the 2 preferred sites or the 2 best sites. So the factors there, like when you're looking on the left side, the property characteristics, those are very highly important for getting just the adequate size of the where you're going to put your plant, because you got to have enough property for it, obviously. The ease of construction, the accessibility for the treatment logistics, the long-term treatment logistics, such as chemical and material deliveries and the sludge hauling. The intake and the water quality, very important for environmental protection, of course, but also for the ease of construction and having your stable raw water quality to optimize the treatment efficiency. And the discharge, again, also very, very important for environmental protection, but also important for the ease of construction and having it deep enough for a good mixing capability within a discharge body of water. And then the desalinated water delivery to the distribution system. Proximity distance, that matters with regards to the cost and using the existing distribution system, so a closer distance is preferred. Power, similarly, proximity distance matters with regards to the cost to get your power there, and a closer distance is preferred. And the social impacts are important with regards to proximity to residential areas, to neighborhoods, and the big truck logistics, such as deliveries and sledge hauling, that are going to continue, for the life of the plant there for the treatment operations. Next slide, please. So all sites were considered, and again, this was from the workshop, and this is very, very high level, but each of those colored areas show sites that were evaluated. There was 21 of them that were considered, and then it's again narrowed down to 4 candidate sites, 2 in the Inner Harbor and 2 at the La Quinta Channel. And just very, very, very briefly, but kind of going from left to right there, starting at the Inner Harbor. So at the far left, you got the CC Polymers, which was the former M&G plant. And, the issues with that one, it was eliminated from consideration because it was non-potable water. And there was a 2018 evaluation that identified many operational concerns with this one. Next to that, adjacent to it, is a Port of Corpus Christi property, but the intake location was too close to the CC Polymers industrial wastewater discharge, so that site was eliminated. A little further down, as we're heading east, there's another port property, but the challenge there was that your waterfront, and so your intake and your discharge, where are you going to put that? They're too close together, and there's other industrial wastewater discharges that go in there too, and so you're trying to balance all that and avoid those out. There was another site, Elementus Chromium. It's too small. You could build a 10 MGD plant, which was okay, again, when they're originally talking, but now we're talking bigger. But 4 acres is about as large as you can get a 10 MGD, so you would never be able to expand there. We have the preferred site, which is located at Nueces Bay Boulevard and West Broadway, and there's a candidate site that's further down on Broadway. But of the 2, the preferred site is less encumbered and closer to the water, so again, your costs are going to be down. Moving further to the east over to La Quinta Channel. So there's a mix of properties here, and the preferred site is actually on Occidental Corporation, on their property, and it's the red kind of triangular-looking dot up at the top there. And that site is actually located directly across the street from the San Patricio Municipal Water District, which was what made it the most attractive. There was another candidate site owned by the port, which was further down to the left on the La Quinta Channel. A number of these other sites, similar like in Inner Harbor, it was the intakes and the discharge. Trying to get it sited, if we use that property, how would we get the adequate distance separating the intake and the discharge from each other? And so those were the major challenges with a number of those sites, just very, very narrow. And then as we move further, there's the four sites furthest to the east. There's a blue dot, and then a big white triangle around Ingleside, and then a red and white spot, and then a blue area over on Harbor Island. And all four of those sites had pretty significant environmental concerns due to seagrass, fish nurseries, fish larvae migration routes, and then some of those, kind of as you went further east, like from Ingleside, the big white square, and then out at Harbor Island, it was the distance to the San Patricio Municipal Water District, because again, the preferred site's directly across the street, and with the desalinated water, it's very pure, and so you have to blend it somewhere. And so the idea over on this side is that for municipal use, you would blend it over at the San Patricio Municipal Water District plant and then distribute it out there. So you have those proximity distances, from Harbor Island and from Ingleside, just to get the water to the San Patricio plant. And then out on Harbor Island and to a point over in Ingleside a little bit as well, but it's the high voltage transmission lines. You're going to use a lot of power. And out at Harbor Island, you're looking at having 7, 8, 9 miles worth of high voltage transmission that you're going to have to build in order to bring power out to there. And then also, I guess the closer you get to the Gulf, the more hurricane prone as well. Next slide, please. Actually, oops. All right, so again, balancing the three-legged stool of economics, environment, and sustainability. These are, again, on the left, you got the screening criteria that were used, and then the evaluation criteria are listed here as well, again, which focused on economics and environment aspects. And really that's about which sites are safer for the environment, the aquatic fauna, the seagrasses, the migratory routes, the fish, endangered species. And like our COO said, later on, as part of this, there's going to be a discussion about the environmental discharge study in this workshop. And the other aspect, because you got your environment aspects, you got your economic aspects, which sites are more cost effective, and that goes to kind of the constructability of it, the ease of construction, and again, the power accessibility and the water distribution accessibility, how far is that? With that, I will pass off now back to the COO. Thank you.
Thank you, Kevin. Any questions for Kevin, feel free to ask. I mean, that's a lot of information, and to Kevin's credit, I just asked him this morning to come to go back over that information. So hopefully, I hope you find that useful, that's information. I'm sure you probably all remember that from back, but I think it was important that we get some context here that we ended up with these two sites. So things that you're going to hear. Yes, ma'am. Yes, sir.
Go right ahead.
Mike, have we discussed with any of these sites, have we discussed a partnership with any of the refineries that have cooling tower water that they discharge on a daily basis that we could use as source water?
I have not personally had that conversation. I know we've been invited. I think you and I have been invited, but for reasons we couldn't go out to the CC Polymer plant to look at some of their processes there, but no, I have not.
Okay.
Have not talked to.
But that could be.
It's possible.
Possible.
Yeah. But so just kind of put this in perspective. We're talking everything you're going to see today is based on a 20 million gallon per day plant. So and that's desalinated 20 million gallons per day desalinated water. So that's going to kind of drive the conversation and the decisions that we're looking at today. I know one of the questions that was brought up at the retreat was site expandability. We're going to talk about that. Was environmental impact. Obviously, we're going to talk about that. And then cost. There is the cost. Even though the desal plant itself is very similar in cost, but the locations are not similar. They're dissimilar. And so there is added costs or reduced costs depending on the site that we select of these two.
So that's your explanation, or that's the determination that was made for eliminating Harbor Island as a potential site is because of its location and proximity for electrical grid, connecting to our public water
Yes, those
systems.
yes, sir. Those
But
played a role in it.
those issues are not impossible, they're just more expensive.
Correct. That's correct. It's, the environmental impact, I think, as Kevin described also, was a big issue on that one too, that the committee.
Now, that was my next question. Did you look at anything other than, was there any other issues associated with the Harbor Island location besides
Okay.
its locale and distance from electrical and
Okay,
piping?
let me throw that to my team here because obviously I didn't, but
So the answer is yes, we did. And one of the big factors is the environmental.
Can you
effect.
turn your mic, get your mic on?
Can you hear me now?
Yeah,
Yeah.
Okay.
better.
One of the big factors, you are correct, one of the big factors that we looked at was the environmental effect on the discharge. And the area where Harbor Island is a sensitive ecosystem. And so at the beginning of the analysis for site location, it kind of fell out because of that particular and important issue.
okay.
But if you took that discharge offshore from Harbor Island, that problem goes away.
In the coast.
So I think reading the Hart Institute white paper that they provided, going further out was sort of the best possible way to treat desal water. But then you get into massive expense.
Yeah,
Yeah, but yes, sir, that's
my
correct.
point is, I want to make sure we haven't eliminated Harbor Island just because of
Yep.
its locale, that there are, if,
There are,
we
there
can't.
are surrounding circumstances. Now, the committee, that's why I had Kevin go through that very quick but lengthy process, evaluated all of these things. You saw the list of things that were qualifiers and disqualifiers from each individual site. So I'm just saying that you put together a group of professionals like that was assembled, that council approved to assemble to look at those things were looked at. So we can go into more detail. I'm sure there's there's notes and records on, I'm looking for Kevin, there's notes and records. If you would like to see those, we'll definitely research those and get you that information on what qualified and what disqualified certain sites from moving through the process. Because I think what they did is they started with 21 sites, and then as the sites were disqualified, more information was gathered for the remaining sites until it's just sort of a survival of the fittest as you narrow that.
no, I understand. I just want to make sure that we didn't eliminate that
Yes, sir.
site just
Okay.
because of those two issues.
Yes, okay.
And you're right. It wasn't just because of those two issues, it's because of multiple issues. The power distribution, the environmental sensibility in that area, and the idea of where was that area going to be able to achieve the correct permitting. And so, yes, if you throw out the idea that you take everything offshore, yes, but time, effort, and money is involved with that question.
Okay,
Right.
thank you.
Yes, sir.
Councilman?
If I may, I understand those issues, but for me, I'd like to see what the best thing is and what it costs, right? I know that it may cost too much, and I know that,
Okay.
but I would still like to know, ideally, if we could do everything the way we wanted to do it, a perfect desal plant, where that location would be, would it go offshore, where would it discharge? For me, that's kind of important to know what the perfect plant cost, $5 billion, whatever it may be, and then look at what we're giving up and why we are and what the cost of giving that up is, so that we still have comfort that we're getting the best for what we're doing,
Okay.
right?
Well, let us revisit the selection process. I think that's what if I hear what council is asking, they want us to revisit the selection process and see their notes on that.
Right,
we
and
can.
there was, Mr. Murphy, there was a report.
Okay.
There was a report. I don't recall how in-depth it was, but I think, I agree. I mean, those
Okay.
they're valid concerns. Obviously, one of the greatest things that we've talked about is, right, everything comes with a price. And so if it is a wonderful location, but you have to pipeline everything out, which is going to raise it, however many millions of dollars, which our residents are going to pay for, if not, right? If it's not something that's covered under the revenue streams we currently have, then it's something to consider. But I think you're saying we need to be able to consider that.
Right, because, so you can evaluate the risk, right?
Mr. Martinez, can you
So-
talk into
so-
the mic?
Yeah, sure. So you can evaluate, if there are some risk with doing it something else, is the cost of that risk worth what you're giving up, right?
Right.
Right.
Well, in our presentation, as we get further into our presentation today, we're going to show on the two sites that council originally selected that moved us to this point that we are at today, we're going to show you the risks have been pretty much negated as far as environmental impact. And we're going to go through that here in just a few minutes. But I understand what you're asking for, and we'll go back and
So
we'll
we'll
pull that
just
report.
notate
make it
that as
available.
the first thing,
Yes,
is to
ma'am.
look at that aspect of it. Councilman Lerman?
Absolutely.
Thank you, Mayor. Yeah, Mike, I have the same two concerns that my colleagues do, as far as the cost factor of a perfect location. I want to see that because I want to make that decision. I want to make sure the taxpayers are going to get their money worth. If it does cost us an extra $1 million, $2 million, $3 million, what's in addition to $2 or $3 million when you're spending $226 million? I mean, do we have a set amount of dollars that we're going to be spent that you were told to keep it within this dollar range? What if it does cost us $250 million instead of $226 million? But it's going to give us a better product, for the long term. It's going to give us the opportunity to grow. Just with one company growing in the Portland area, that's going to take, I don't know, 20 million gallons or something per day and stuff like this. What happens when the next two companies come in? Is that plant big enough to serve them?
Right.
We're going to be in the same situation again. I don't want to be in that situation. I want to make sure I have the acreage. I want to make sure even if we have the pipeline that we have to go out and put a pipeline half a mile down the road to empty it out in the right area that has the currents to disperse it, so be it. But I want to be able to make that decision.
Okay. That's fair
Okay,
enough.
and the environmental part, I'm concerned for one of the locations that you and I spoke about already. It's the Inner Harbor. We don't have a dispersion for it to be dispersed in that. It's going to settle in that area. I'm worried about the Rochelle Foundation putting our oyster beds that they're going to put right there in the North Beach area, that them getting polluted with too much of the brine. Even though there's experts out there telling me that it's okay with they can filter it with no problem, this and that. But then I have 5 more telling me they can't handle that. You'll kill them. So they're going to spend millions of dollars, approximately $33 million, to put, that those oyster beds in the North Beach area. I have a big concern about that.
Yeah. And I appreciate that, and I know you didn't. There's a concern, and it's a legitimate concern. So we're going to show you the results of the environmental study. We're going to show you that, and I'm not sure it's going to alleviate your concerns, but it's going to show you what the data and what the facts of months and months and months of modeling has come up with. So we're going to walk through that in detail. Feel free to ask as many questions. When Maria gets ready to do her presentation, we're going to talk about the environmental impact on both locations, because I want to keep us focused. I mean, I hear what you're saying, and we're going to get you all that information. But for today's meeting, I want us to stay focused on these two sites, because that's what we've been working on. Now, at some point, if you say, let's pivot off of this, let's go some other direction, then we're obviously willing to do that. You're the city council. You tell us what to do. But we're going to stay focused on those two sites, and hopefully we'll answer a lot of these questions of what you're talking about. And I do have an example of an extending pipeline of what that costs, and it's not just $4 or $5 million. It's a bigger price tag than that. But we'll go over that. That's part of the presentation, and we'll talk about that. Okay?
Wonderful. Thank you, Mr. Murphy. Councilman Hernandez?
Yes, sir.
Thank you, Mayor. For me, this is ultimately a financial question. I assume that with our expertise in environment, in the environment, will mitigate whatever needs to be done. Salinity levels that we've been monitoring over the last several decades, it's, up and down, 40 parts per million, 30 parts per million. I mean, I think the salinity levels are somewhat of a hard to gauge based on the time of year, temperature, how much rainfall we have. That it's going to be, I think the environmental aspect is going to, we can address those. So ultimately, this is going to be a financial discussion. And, based on the calculations that we've done, it's been my experience that government tends to cost twice, to build something costs twice as much to do as the private sector. So in looking at that aspect, your elimination of certain areas is based on our own calculations on how much it costs us to do things, but not what it costs the private sector to do things. So one of the reasons why several of us on the council had asked for the RFI to give the RFI respondents to actually give presentations was to get kind of a glimpse into that. However, under an RFI, it's not, there's nothing solid there. So what I've always asked for, and what I don't think I'm seeing here yet, is to get those estimates in a very real set, real numbers, and that's why I asked for an RFP to be issued to those RFI respondents in order to give us their numbers and what it would be and what any sites they selected, even if it's the sites that we've identified, or even other sites for where other permits are being sought after. Without that insight, without that financial insight from other entities, it's hard to make a decision on $222 million without really with only having our own insight into it. So in looking at what you're providing today, is any of that aspect going to be presented?
No, sir. So here's where we're at today. And you and I have had this conversation, and I appreciate our conversation together and with everybody. But we cannot, and I've talked to major contractors, worldwide contractors who've done desal plants. Matter of fact, just last week I met with Jacobs Construction, which was one of the largest general contractors in the world, not just in the country, but in the world. They're doing a $1.8 billion plant right now in Houston. And I asked them that very same question. I said, can you give me this information? If I sent out an RFP, would your company be able to respond to the RFP, not knowing if we have permits in hand and not knowing the site location? They said they wouldn't be able to do it. They could do it, but it would have no meaning. They wouldn't be able to, it doesn't mean anything until we hand them, say, I've got permits for you to do a site, because it's literally what we're asking a contractor to do is spend hundreds of thousands, if not millions of dollars, just to prepare an RFP that may never happen. That's the difficult part that we're in. So you're 100% right. We're going to get there. We're going to do that. But you're on step 12. I'm trying to get us today to step 10. And then once we come up with step 10, which is permits and a site location, then we go into procurement. And we'll talk about that. The last slide we have on the presentation today is talking about procurement, which is where you're at. But you're asking a question.
That's not what I'm referring to. I mean, we during the RFI presentations, and hopefully you had the opportunity to go look at that, a lot of these companies asked us to include them sooner rather than later, so they can help in the process and
Absolutely.
the permitting. So by going forward in the direction we have eliminated a lot of opportunities with that.
Yeah.
Okay, so that's what I'm referring to in terms of including them in the process. By not doing that, we basically eliminated a lot of opportunity to do that. So, I mean, we're almost a victim of our own choices. But even with that, there's other options out there. Now, it wasn't specifically limiting it to desal. There's other options out there. There's groundwater, there's wastewater reuse, and ultimately, like I said, it's a financial decision on a cost per 1,000 gallons over a long period of time.
Right.
Okay, so, without having that information, you're giving us a choice of we're going to do the design build or design build operate or nothing is basically the choice you're giving us. And the choice either between design build at either La Quinta or at the Inner Harbor.
Sorry, I didn't mean to. So not necessarily. Because whatever we gather, whether it's the permits that are currently pending right now, we've got 4 permits pending at TCEQ. The first step is to get those approved. Once we get those approved and we have a site selected, they're
For desal.
For desal, they're transferable. But we've also looked, Councilman, we've looked at groundwater, we've looked at aquifer storage, we've looked at water reuse. I'm leaving one out.
Wastewater.
Yeah, well, we've looked at those. Those are all dependent on rain. You have to have rain to replenish those sources. What we're looking at today and what we put on the front page is drought proof. Drought proof. Because in a drought, we can have more surface water, we can have more groundwater, we can have aquifer storage, we can even do reuse wastewater. But they're all dependent on available rainwater or rainwater replenishing that. But you all know, once you get into the drought, that's not there. It's not replenishing. Everything is low. And I think Gabe will talk about it a little bit in his presentation, but if we're in like a 2011 drought of record, there is no replenishing water coming in. Everything is getting close to being shut off. And so that's why council voted on the 75% trigger, which we're going to go over. But kind of stay focused on that. But to answer your question, no, it doesn't necessarily cut anybody off. Because if the council decides, well, hey, we don't want to do it, we want somebody else to own, operate, finance, build, then we transfer the permit to them. There you go. That's an option. I'm just saying that's an option. All options are still on the table. I hope you don't think that we've cut anything off and we're not looking at all options as far as procurement. And when I say procurement, I'm talking about design, build, manage, maintain. All those are still on the table. I mean, so all we're trying to do is get it to that point where we can address the questions that you're answering.
You know, what we heard from the RFI respondents was to include them earlier than later.
Yeah.
And we're not doing that. We're not even considering it.
Yeah.
So that's why I'm saying is that we've eliminated some options.
Yeah.
Can we agree to that we've eliminated some options?
No, because I think once we get through this point, so you're talking about location. Is that what you're talking about?
I'm not talking about
if you're not talking about location,
I'm talking about
then
process,
we're going to
right?
bring them into the process. I mean, we've got to. The only way you can design a project and build a project of this size is you've got to bring the contractors and the engineers into the process. They've got to be part of that process. It's just that we're not there yet. Like I said, you're on step 12. We're trying to get to step 10, where I'm trying to have a approved permit and a site. Now, I hope I can get both. I hope I'll have both of them.
Well,
so we're gonna,
go on with your presentation.
For clarity, we're going to focus on the 2 locations that have come about because of a process that has taken place for how many years? I don't know.
it's been a while.
5, 6 years. So that does not mean, Councilman, because I hear you, but that does not mean that we're not going to take into account or look into what you're asking. But today, because we can be here for 3 days straight.
Yes, don't
24 hours a day. Today, we're gonna talk about these locations. That is
Yes.
what this presentation is about. We want everyone to ask questions. We want you to make notes and say, okay, I've got to come back with this. I've got to go find that.
Yep.
But let's cover what has been done to date.
Okay.
And then we will move forward, pivot if we have to, do whatever it is we need to do after we cover this presentation.
Okay. So
Thank you.
we've talked about permits. Permits that's the linchpin of this whole process. If without the TCEQ permits for discharge, intake and discharge, we cannot move this process forward. So Esteban is going to walk us through where we are in the permitting process and sort of the next steps to describe that. So Esteban.
Thank you, sir. I'm real excited, Mayor, Council, to report to you that the permitting process is moving as expected. We have 4 permit applications with TCEQ. Those are 2 water right permit applications and 2 discharge permit applications. The water right permit applications have both been to notice. We've even had a public meeting on the Inner Harbor location. That public meeting went really well. We also expect to have a public meeting on the La Quinta site in the near future. So we're excited to get out into the community and have that particular public meeting. So that's a great movement on that water rights. So the water rights are moving forward as expected, even with a COVID year that we had. And that took a little bit from the TCEQ. And then talking about the two permit applications for the discharge, the TPDS permits. As y'all we announced yesterday, the big step was submitting to the TCEQ the final modeling reports. That's a great momentous activity in the permitting process. To get to that point, I want to make sure that everybody's aware that it took a lot of work in the back end, working with our consultant and the TCEQ to get to that point. We needed to do our due diligence. We needed to do what was best for our area, go above and beyond, taking sampling, taking water quality sampling and velocity sampling within those two site locations to get that modeling so that we can use real data and not just assumptions. So we're real excited to review that with the TCEQ, and that is moving forward. So we expect those to be granted by the TCEQ in the near future. And let me go ahead and turn it back to Mike for the next speaker.
So just a timeline, I think what Esteban is talking about, we're hoping sometime this fall we'll have a decision from TCEQ whether or not the permits are granted. There's still a lot of work to be done between now and then. We're going to have to do a public meeting again. And if you've sat through a public meeting with TCEQ, you know they can be, it's a humbling experience to say the very least because of the comments that are being made. But we're fully equipped and capable of doing that, so thank you for that. So council retreat, let's kind of go, I started talking about that a little bit earlier, but at the council retreat, what I'd heard was that the process is sort of stuck, and my goal is to get it unstuck. And that doesn't mean that we're going to go this way or no way. What this means is we're going to move this process forward, and Councilman, if it's like what you're talking about or what others are talking about, at least we're going to be moving forward instead of not going anywhere. And just kind of look, there's some comments that just a snapshot of some of the things that we overheard during the retreat, but I'd like to close with the one that Councilman Pusley says was, I'd like to see council come to some sort of consensus about the direction we're going to take. And I think that pretty much summed up the retreat part when we were talking about desal. I know there was a lot of other things going on in the council retreat, but I think that was a very good summation of what we were looking at. So the 2019 council meeting that sort of, like the mayor was referring to, that gave us our direction of where we're going and why we're here today. Many of the things that were talked about, and we've already touched base on a little bit, but we're going to go into more detail of what the 75% trigger point means. That's based on the firm yield of our water supply. And once we hit that 75% point, and it triggers the need for additional water source. And so there's a lot of conversation about that. There's a lot of very detailed information, but Esteban is going to take a sort of a high-level executive summary look at that, and then questions follow. So Esteban.
So supply and demand, please, next slide. Okay, supply and demand. It all starts with understanding what a
I'm sorry,
firm
can I
yield.
just interrupt you guys for a minute? Can you go back to that slide, the one you had before we go to Esteban?
Yes, sir.
This slide is critical in setting the context for the workshop today. So it was 2 years ago, approximately, that the then mayor and city council voted on selecting these two sites, the Inner Harbor and La Quinta, that you can see on this slide. And so the staff has been working since that time with these two locations as the two locations to work around. Right, this slide, did you go over this, Mike, at all?
We've got that.
You gonna go back?
in upcoming slides. We're going to be talking about all of that.
Okay, so just, this is an important slide because it sets the context for a lot of the work that has been done, both in the modeling and in the financial application to the Water Development Board. They were very site-specific because those are the two chosen locations, right? Even the permits that were submitted to TCEQ are those exact two locations. So that's why we keep talking about these two locations. So if the council chooses to deviate from these two locations, and we have to start over in some respects with permitting applications, even with potential loans from the Water Development Board. So things like the permitting, the financing, and how we phase these in could change if these two sites are not considered by the council. So I just want to, yeah.
Yep. And we'll talk about that. We've got that in upcoming slides where we'll go into more detail about what, if we decide to go away from these two sites, the consequences, or if you decide Inner Harbor is not the Phase 1 site, you want to choose La Quinta as the Phase 1 site, there are financial consequences and there are time consequences associated with doing those sort of things, and we're going to go into detail what that means. All right. Thank you.
Okay, supply and demand. You know, as the water resource manager, I always keep an eye on what's going on and looking at our supply and demand. And it all starts with an understanding of a firm yield supply. Our firm yield of supply is the amount of water that I can guarantee during a drought of record. That includes all current water supplies, from Choke Canyon, Lake Corpus Christi, Lake Texana through that contract, and the water rights on the Colorado River are all calculated within that firm yield. The City of Corpus Christi City Council established that when demand reaches 75% of firm yield, a new source of water needs to be added. Within the 2022-2023 timeframe, with the new growth in the coastal bend, our projected demand will meet or exceed that 75% trigger point threshold of our firm yield. With this addition of a drought-proof seawater desalination plant, we reduce the risk of exceeding that 75% trigger point.
So you see right there, 2026 right now is our timeline. That's our goal line of being able to deliver desal water. If we move forward with this process and we stay on track, like the city manager was talking about, these two sites, we can deliver water by 2026. If we deviate from that, not only the cost will rise, but the timeline will be shifted, and it will not be 2026. If we have to go back and start the permitting process over, or if council selects for us or directs us to start looking at other sites, then that timeline will shift from 2026. And depending on what the direction is, we'll come up with the new timeline. Yeah.
Mayor, quick question on this.
Sure.
Does that yield for Mayor Road's pipeline Phase 1 include what is currently we're receiving from that, or the actual water rights? Because I understand that there's a gap there.
Okay, so we do have slides. I'm not cutting you off. We do have slides, and we're going to talk in depth about the Mary Road pipeline. But it does. Gabe, you want to just quickly jump to that, and we'll talk about it
Yes, sir.
real
It
quick.
does include what our water rights and water contract entails. That's what the firm yield. It's all
It's a
included.
firm yield, so we're looking
Right.
at what we're water rights, not what we're currently receiving. I
Yes,
believe.
sir.
We're not. What's the percentage that we're receiving right now?
2/3
2/3.
currently. Yes, sir.
Okay, thank you.
Okay. All right, so two sites. We've talked about it. These are the two sites we're looking at. This is our location. You've got the Inner Harbor site, which is already is located and it is on part of a, it could, let me just back up. It could be easily attached to our existing water system, and we have a customer base ready to take that water right now. So the desal water is potable water. It goes through a treatment process. We're going to describe that in more detail here in just a minute. But it is a treatment process that makes the water readily available, so we can put it immediately into our system. And what we're looking at is 20 million gallons originally. And the reason we were talking about 20 million gallons is because we're talking about right sizing. Now, I know there was questions about site expandability, but there's a lot of men and women in this audience who I've talked to about what is considered right size for a plant. You do not build a desal plant for more than you have customers to take that water. That is sort of the death knell to desal. Everybody that I've talked to says you've got to build the right size plant. You can't go build a 50 million gallon plant if you only got 20 million gallons of demand. Does that make sense? So right sizing is critically important. So we're looking at initially starting with a 20 million gallon per day plant And both of these sites, you'll see that our numbers correspond to that. Now, Inner Harbor has the ability to be expanded to 30 million gallons per day. That's the maximum. Now, some will tell you that once you get to that 30 million gallon per day level, technology will have caught up with the process, and you should be able to get maybe 10, 15 million more out of the new technology. But right now, it's 20 million, expandable to 30 million. The pros and cons of that. So really, it's just what meets the trigger point that Esteban just described. So this will meet the trigger point. 2026, we'll have that water available, and it'll be running. It's in close proximity to its demand, which basically what that means is we can readily apply it to our customers right now. We can do it right now. And so we'll talk about how that works when Gabriel talks about water quality. And then we've also got the aquatic impact, or the impact to the aquatic habitat, or basically the environmental discharge study. We're going to talk about that. The cons of it, it's only expandable to 30 million gallons on Inner Harbor. And then, obviously, when you're building a project of this size, you're going to have issues with traffic control on the site. So we're going to be looking at those. So the total cost right now, this is the engineer's projection as of Monday. Sorry, get away from the microphone. As of Monday, $222 million to build the Inner Harbor plant. And then, of course, we got the operation maintenance cost. That also has the asset lifecycle maintenance on it. And then the cost per 1,000 gallons at $3.73 per gallon. Got my glasses, I need those. Okay.
Hey, Mike, and then just to reiterate or say it again, that you can see under the pros, the Texas Water Development low-interest loan was approved specifically for this site based on council input 2 years ago, right? So Mike's done some initial discussion, I think, with the Texas Water Development Board. We could get the loan changed if we needed to, but just to be aware, it was actually approved for a specific site, which is this site, based on council's direction 2 years ago. So there's some due diligence that would have to be done if we change the site. And then another important thing to reiterate again is the 373. You can see in the far right, the cost per 1,000 gallons. That's an important dollar, Councilman Smith knows that, an important dollar figure to keep our eye on as we discuss location or site. If it gets too high, it's too costly of a water source, and it may not be affordable, right? But so 373, and you'll see the price for the other location as well, based on some early estimates.
Okay.
Thank you.
And if you guys want to go deeper into the SWIFT funding, the Texas Water Development Board funding, we're prepared to do that. We do not have that part of our presentation, but we're prepared to go deeper if you guys want to talk about that. Okay. Next slide. So La Quinta, same thing, pros and cons. It meets the trigger point. We can do that by 2026. Proximity to San Patricio, and it's expandable to 40 million gallons a day. Like I said, we're going to start, regardless of which site, we'll start with a 20 million gallon plant, and then we'll move up. It does have a larger volume of water, and like was said in previous meetings, the velocity, the natural higher velocity of the La Quinta site, that harbor site, is a benefit. But we're going to show that with the environmental impact study, it's really, it's nice to have, but it doesn't really impact the water quality, and we'll go over that. And it basically says that negligible impact to the aquatic life and whatever. Additional costs for construction of pipeline Corpus Christi. So you see the prices over here, 20 to 30 million gallons per day, $243 million. Now, like I said earlier, the desal plant on each site is very similar, but the sites are dissimilar. And what that means is the La Quinta site is further away from the body of water that it's going to intake and discharge from and into. So that adds an additional $21 million to the project. And then the cost per 1,000 gallons, just that $21 million raises it from $3.73 to $4 per gallon, like Peter was talking about. Now, this does not include the pipeline, because what we're trying to do is compare apples to apples here. And to do that, Right now, on the La Quinta site, there is no customer to take that 20 million gallons per day. So it doesn't really make sense to move that water when there's no customer to take it. San Patricio provides water to that side of the harbor. They're already supplying, we provide San Patricio with raw water, they treat it, and they deliver it to their customers. So without a major customer on that side, you're building a 20 million gallon plant, but nobody to take the water. And this is not a build it and they will come process. It's like they will come and you build it. And so meeting with a lot of the men and women in the back of the room here with the port industries of Corpus Christi, it's like we can build the plant, we can build a desal, but not until there's somebody there ready to take the water. Because by the time, let's just say some type of manufacturing company builds and they have a need for 20 million gallons a day, then we could initiate the La Quinta site and have that site built before their plant is ready to take water. That's sort of the thinking there on the phase 2, if that makes sense.
Okay, Councilman Smith, I think it's a question.
Yeah, okay.
I didn't quite get it, Mike, excuse my denseness, but the $4 does not include the pipeline to Corpus Christi?
No.
So
No, because-
it's really not, is we're looking to the end user then, it's not an apples to apples. So
Right.
actually, to the ratepayers who eventually pay, whether they're
Right.
San Pat Water District or whatever, that there's much more cost than at $4. Am I
Yeah.
hearing that?
That
Because
will
they spent
definitely go up.
$60 million Exxon on that pipeline or something like that?
Yeah, so Exxon owns that pipeline,
Yeah.
the line that you're talking
But what I'm
about.
saying is you're telling us we're $3.73 on one side and $4 on another, but that's really not the case, because if we build it over there and we don't have the demand over there and have to put a pipeline in, we're probably
Mm-hmm.
looking $4.50, $5?
Probably upward of that.
Okay.
Because we'll go to the next slide.
Yeah. That's
So this is what you're talking about, Councilman. We wanted to put this in here.
Mr. Murphy, if you'll hold on one
Oh,
second, we
yes,
have another
ma'am.
question.
Real quick, Mike, just for reference, have we done a calculation on what our water cost us now coming to our treatment plant, or actually what it costs out of the treatment plant based on taking it from the sources we have now?
Yeah, we got that.
Do we have that number?
Yeah, who wants to take, I've got 5 people shaking their heads ready to push their button.
Yes, sir. Yes, so from Lake Texana, right now, the cost is $2.23 per 1,000 gallons.
223?
And then for Lower Colorado River, it's $3.05. And that's based on our 2020 numbers
Okay.
for the demand of.
Now, does that include the cost of the pipeline?
It's included in there.
That's cost of the pipeline, cost of the treating the water, getting it through.
All the way to delivery.
All the way to delivery.
Yes, sir.
That's what our costs are now.
Yeah,
For those two.
right. That's why I pointed out that $3.73 or $4, at some point, it's not a viable.
It's not economical.
Exactly.
Yeah.
And that's
No,
why
I
the city's been at this for a decade or longer.
Yeah.
10 years ago, though, it was too pricey. Electricity was more expensive, the technology wasn't there. So 10 years ago, the then city council could have said, hey, let's build that desal plant, but the economics weren't there. Today it is because of better power pricing and better technology. So that $3.73 is not a bad price compared to our $3.05, say,
Right.
when you have an uninterruptible supply of water.
Exactly.
And then just one other thing to point out is that it's been stated in the public before, but the 2 sites, the Inner Harbor, that was envisioned to serve the customers on the mainland, right, of Corpus Christi. It was always thought that La Quinta would help to serve customers that would be forthcoming in that area. There was one, in fact, that was planned to come, and I think with COVID and other reasons, it did not come.
So if we got another Exxon that built over in that area, that would be an appropriate.
Any type of large water user, yes. Right now, there's no one that we know of that's ready to come here. There was at one point. And so that's why that was an alternate preferred site, but it was also site number 2. And the direction was, let's pursue site number 1 because we know the customer base is there right now.
Well, I guess I misunderstood. I always thought that the city, before I got here, was only looking at site number 1. I didn't think they were talking, y'all were talking
We talked
about.
both sites. In fact, that's why we have the permitting submitted to TCQ for both sites.
Okay.
But there was a phased approach. It was do site 1 first, And then if there's a customer base, proceed to site two.
Okay.
Yes,
And
sir.
that's exactly right. And from the beginning, when I got here 5 years ago, that's how the project was developed. That looking at a phased approach, what would be best for the environment, what would be best economically, and what would be best sustainability. And so that has been the drivers of this project from the beginning. And you're exactly right.
Okay, okay, very good. Thank you.
Good question, thank you. So,
Mayor,
I'm sorry.
the previous number from the lower Colorado River was 467. How did that go from 467 to 305?
Right, so in 2020, we pulled a lot more water from Colorado compared to 2019, and that's what drove the cost down. So the more you use, the more economical it is per 1,000 gallons.
Okay, so the Mary Roads Phase 2, which we get the water from lower Colorado, merges into Mary Roads Phase 1, correct?
Yes, sir.
So did we take less from Lake Texana? I mean,
No, so at that time, what we did is we took less actually from Nueces River. So we pulled more from Mary Roads Pipeline and less from Nueces River. And that was in an effort to conserve our water supply because we were getting toward a drought during that time in 2020. We knew it was coming, so we tried to use less from our reservoirs and more from our Mary Roads Pipeline.
Okay, thank you.
Okay, and we do have a deeper discussion into the Mary Road pipeline in just a minute. So we'll go into it in more detail. That's a great question. So Councilman Smith, back to your question. We intentionally did not include the pipeline in that. Now, if we tried to bring them and make apples to apples, this was the slide that I'm trying to get to. A pipeline will have to be constructed, like Peter was saying, to serve the people on the south side of the harbor. Right now, if we just built the desal plant, it's mostly for a commercial use. There's not really a use for, or there's not a benefit for the residents on the south side.
Okay, so as of today, if we do that, we've got the 243 or 53 million for the plant, plus the cost of the pipeline, which will be another 60 or 100 million dollars. And the plant doesn't do us any good if we don't put the pipeline.
As well said. That's exactly right. So we've estimated these costs. So we looked at two options. The city manager had us look at two options. One of them is to go around, which is the blue line. There's already a pipeline in place over there that we could probably work within those existing easements, easier to get to, but it's a longer line. Or we could go underneath the harbor, which is a shorter route, but more difficult construction and obviously more expensive. And then, like the city manager was talking about earlier, it impacts timeline, because now you've got permitting to get under the harbor, which brings in local, state, and federal agencies that you have to get approval from. And all that means time, and it's probably 24, that the timeline up there for 2026 probably is pushed back by 2 to 3 years by doing that. So there are consequences with doing these things.
And in that line, we may put stress on our transmission system too, because it's hitting in just kind of in the middle of it rather than at the O.N. Stevens. It's designed to transmit all that water.
So Gabe can talk about what it would look like at O.N. Stevens if we went with that.
Okay, thanks.
Go ahead, Gabe.
Right, so, yes, so generally, it would be better if we took it to Owen Stevens through the land that way. And that's because we are geared toward delivering water from Owen Stevens. If you go under the water and the ship channel there, the cost of the pipeline also does go up significantly. If we're building it on land, you're looking at about $600 per linear foot. And if you're going underwater, it's about $1,500 per linear foot. And now those numbers are based on known pipelines that are being built currently or have already been built. Right there.
So we estimate, Councilman Smith, you were right, it's in the $100 million price range to build, regardless of which route we take. It's a substantial amount of money added to the project. We're estimating somewhere between $100, $120 million to build those pipelines.
Yeah, can I just jump in? So initially, if you see in the map here, staff showed me just the blue line, but it seemed like too long of a distance. I didn't want it. It seemed like we didn't want to do it, right? I'm like, why do we have to go way over there? But maybe Estefan can help explain why that route is chosen. But I did have them do that alternate route coming through, what seems like a more closer delivery system. But the price tag and we didn't put it on here because it's the rough estimates, but it's $100 million more dollars or even up to 120, I think is what you had on the land route.
And
So
then
it's not just a couple of million to get
Right.
the water delivered because there's no customer on the La Quinta site. You add 100 million to the price tag. So what was a $200 million, $243 million plant becomes a $343 million
$400 million.
plant, right? But Estefan, can you explain why, just so, because to the layperson's eye, it's like, man, it's a long, you're going
It's a long,
Yeah.
about 28 miles, a pipeline, but that would be easier than going through the shorter, because like, we've said, you have just permitting alone, you're gonna have to deal with the Army Corps of Engineers. You go through a very sensitive ecosystem with the shallow, areas, and then you hit the inner harbor, which is deeper, and so you have to manage that. And so we looked at talking to San Pat Municipal Water District, a known distribution line, so that we could have real numbers. And we talked to GCGV and looked at the pipeline, again, $600 a foot. And so that's how we got to the $220 million price tag. So we used what we knew and what was just recently put into the ground.
120.
120, excuse me, $120 million.
And then you'd have a 48-inch line going in a 30-inch line.
And then you have all those particular issues that you have to face also. So it's a complicated situation when you're dealing with having to do that. It's not simple.
Councilman Martinez.
So the Exxon plant over there, isn't that a 20 million gallon per day project? I mean, where they need that much water?
Well,
Yeah, yes, sir, it is.
So if we're going to build a plant that produces 20 million gallons a day over there, why can't we just go to the municipal in San Pat where they take the water there and use it for Exxon? Then why do we need a pipeline going all the way to Corpus?
Right, so that's a good question. So Exxon, actually, they built their line to Owen Stevens, and so we actually already feed Exxon directly from Owen Stevens Water Treatment Plant to Exxon.
But we don't have to, right?
You don't have to, but that's why they built that line. So that line would not be needed if we were to build a plant. But they already have a water feed, and that's directly from our water plant that's existing.
Right. but
And we're already
looking-
feeding them now currently.
But we're looking at what's best for the city and the best way to do it for the city, right? Doesn't that seem like a better way than building a pipeline all the way over there? I just, you know,
You're right.
Right, but we already have the infrastructure in place, and we didn't build it. It was actually Exxon building it.
right.
Yeah, and we're
I
feeding
understand
them
that.
right now.
I understand, but my question is why do we have to build that pipeline going all the way
Yeah,
to
if I
Oh,
understand,
if we
Owen
built-
Stevens instead of just going to the San Pat
San Pat Water.
Water District to get them the water?
Right, and so the demand from San Pat is already 22 million gallons per day, and they do that right now at their treatment process. So if we were to build a La Quinta plant for 20 million gallons a day, then their plant wouldn't be needed.
I think the question, Gabe, and to the panel, is basically cut Exxon off from Owen Stevens and connect them to the desal plant, and then that way you have an additional 20 million gallon per day capacity at Owen Stevens that we could deliver.
Right.
And that would save the cost of a $100 and whatever million dollar pipeline. So
Yeah, so
we would have
it's
to
a
we would have to
possibility,
calculate what that would look like.
But we're going backwards since from what we have currently, I guess. We'd have to change what we're doing now.
But to go along with what Councilman Martinez is saying, if you did that, that pipeline doesn't go away. It's still there, and if we needed to expand at La Quinta and we didn't have another 20 million a day user in the San Pat area, we could pipe that water over to Owens through that pipeline.
Yeah.
You know, we can make a deal with Exxon. We make
Of course, that's
pipeline
possible.
deals like that all the time.
Yeah.
Right.
So that's,
We just saved $100 million.
there you go.
Good job.
Okay, that's a good point. I mean, we'll definitely look at that. I think that's something that the team needs to evaluate and take a look at. So we'll do that. Okay?
Okay. Notation number
All
2.
right. So the critical piece of this, another thing that would be a death knell to the project would be if we had a negative or a poor quality environmental impact assessment to the process. Fortunately, it doesn't show up that way. So I think it's critical that we go through this and walk through this and talk through what it means to have negligible impact to the aquatic life, and then leveraging new technology and that sort of thing. So I'm going to ask Maria Corona. She's going to walk us through this. This is a detailed presentation. So what this is this was what we turned into, or what we sent to TCEQ today to keep the permitting process moving forward. So Maria.
Hi, everybody. Thank you for having us here today. So in the next few slides, I'll be giving y'all quite a bit of information, so please be patient with me. I'll probably be referring back to my notes, and if you have any questions, please feel free to ask. At the end of your handbook, you have 2 large reports, and those are the modeling reports, or what we're calling the environmental discharge studies. In the next 5 slides, I'll try to summarize what's in those large reports. So if you have any questions, please feel free to ask. And I'll elaborate on what negligible means. It means that it is of so little consequence to warrant little to no attention. Based on using over 240 academic and scientific references, we have concluded that we can achieve little to no impact to the bay, including the aquatic life in there. Recognizing that the state of Texas has very limited experience with seawater desal, we're working towards setting a high standard to ensure that the plants will be environmentally responsible. And the way that we have gone above and beyond the regulatory requirements, both for the discharge and intake, to make sure that we have no impact to the oysters or any of the salinity in the bay. The city, in conjunction with our owner's rep, Friesa Nichols, and their sub-plumber, which are the experts in modeling discharges into the Corpus Christi Bay, we conducted modeling that relies on actual site data to determine the discharge strategies to meet the environmental sustainability goals that we defined. With the information that we gathered, working with TCEQ to set those standards to implement that for our projects. And we can go to the next slide. And again, there's a lot of information packed into this next few slides, so please bear with me. We'll be here for a few minutes. Here you can see in this map, you can see the Inner Harbor location relative to other facilities in the area, such as the Harbor Bridge, the aquarium, and other areas. In this site, including potential pipeline easements, which are not shown on this map for legal reasons, the site is approximately 24 acres. And I'll walk you through the practices that we'll be implementing to make sure this is an environmentally responsible project. To avoid and minimize any effects on the intake, we will be using mesh screen intakes with screen openings that are approximately 2 millimeters wide. And to put that into perspective, that is about stacking 2 pennies together. So the openings will be very small to avoid any impingement or entrainment of the aquatic life. And also the velocities at that intake will not exceed 1/2 foot per second. To put that into perspective, turtles walk at about 4.5 feet per second. So it will be relatively very slow velocities into that intake. Implementing these practices will ensure that we will have no impact to the residing aquatic life. And now let me talk about the discharge. The same environmental responsibility was implemented towards the discharge. As recommended by Hard Research Institute, we will be using jet diffusers to limit the environmental impacts of the residing aquatic life. And diffusers provide the quickest method of dilution and dispersion of the effluent. So we will be implementing that to this project. And I'll explain a little bit about what we did to set these limits. We established salinity limits in each zone around the discharge based on tolerances for various native species through their different life stages. And to explain a little further, if you look at the map, here in the Inner Harbor, there's a little half circle. It's red and orange. And in that circle, we have 3 zones. The first zone is called the zone of initial dilution, or the small red circle. It might be very tiny. That red half circle is 50 foot from the discharge. What we concluded to be safe and protective of aquatic life in that zone is 56% of effluent. What that means is that no more than 56% of water in that zone should be effluent. And in salinity, that relates to roughly to 42 parts per thousand. And in the aquatic life mixing zone, which is the middle orange circle, that is 200 feet from the discharge, or that's the edge of it is 200 feet from the discharge. And in that orange circle, no more than 18% of water in that zone should be effluent. And again, this is what we found to be safe for aquatic life in our area. And that translates to 35 parts per thousand in salinity. And once you get to the outer red circle, that is what's called the human health mixing zone, and that's 400 feet from the diffuser. At that point, the effluent will be fully dispersed, and the water will be back to ambient salinity. And in this area, it's approximately 32 parts per thousand. And also, all other production amounts, in the report, we looked at 20 and 30 for Inner Harbor for production amounts, because that's the expendable amount. And also, we looked at different recovery rates. Right now, our current project will be implemented at a 40% recovery rate, which means 40% of the water that we take in ends up as a end product. But we also looked at in the modeling for 50% recovery, which we could do in the future once the technology is there. So we also looked at that for the modeling. Next slide, please.
Hey, Maria, can you stay on that slide just to repeat real quick? So you're saying that in the last outer ring, I guess the darker red, that the salinity levels at that point are negligible, right? You can't really tell.
Yes.
So that means that if you look at North Beach or any place around there where this is for Councilman Lerma, where there was some oyster fisheries established, is the salinity getting there down to the North Beach then?
No,
Because it stops right there? It's
because it's
diffused?
fully diluted by the time it reaches that orange circle.
Okay, thank you.
And let me backtrack a little bit. I kind of missed a little spot here. Like I said, there's a lot of information in these next few slides. So the numbers that I gave you are what we found to be safe for aquatic life, which was 56% effluent in the small red circle and 18% in the orange circle. Now, what the modeling results concluded, for a 20 million gallon a day plant with a 40% recovery rate, we will be achieving dilutions of 10.3% at the edge of the small orange circle, which is 50 feet. So our target was 56. We are achieving 10.3% effluent. And that is what the results of the model concluded. And now at the edge of the aquatic life mixing zone, that dilution is down to 8.5%. And I'd like to kind of give a little explanation of the modeling that we used. So this model wasn't just a random model that we created. This was a CORMIX model that is US EPA approved and supported for mixing zones, for decision support, for environmental impact assessments. So this is an EPA approved model for these types of discharges. And if we can move to the next slide, please.
Mayor, I have a question.
Yes.
Yes, sir.
Thank you. Does this graphic depict the discharge, this graphic and the last one, does it depict the discharge for the 20 MGD plant, or does this graphic also represent the discharge for the expanded plant?
So the graphic depicts both.
It does depict both,
Yes,
okay.
these zones are the zones that are defined by TCEQ water quality standards, and within those zones, based on the salinity ranges and the we find what the best ranges of salinity are for the living aquatic life in our area.
And that kind of leads me to my next question. You talk a lot about salinity, but when you talk about salinity, does it also include brine discharge? Is that one and the same?
Yes, so that's used interchangeably. The salinity or brine discharge, they're the same thing. When I say salinity, I'm talking about the brine that is discharged that is saltier than the water in the bay.
And as this discharge is released into the water, some of the things I've heard is that the brine will actually sink down towards the bottom. Is that a true statement?
For our project, to mitigate that, effluent at higher salinity, then the ambient would naturally sink down. But in order to mitigate that, we're using jet diffusion technologies, and this is essentially pressurized water into the bay. So if you can picture like a hose nozzle, when you hit the nozzle, it just shoots out. So we'll be doing that. We'll be implementing that type of technology to avoid any of this discharge settling into the bay.
When you do that, if you're jetting it out into the bay, wouldn't that, over time, allow the brine to accumulate just at a greater distance from the discharge point?
No, we do not foresee any brine accumulation because of also the bay or the ship channel, which is what we're talking about right now, does have background velocities, tidal velocities, and that dispersed effluent would be moving along with the tidal movement.
So in English, that means the current would...
Yes, the current will event.
Okay.
Yes,
Okay.
yes.
And one of the big things, you're not adding more salt. The salt that you're putting back is the same salt that was in the bay to begin with. We're using the best available technology to make sure that it's mixed into the water body as quickly as possible to get to those ambient levels.
Okay. Thank you.
Councilman
And
Lerman?
I was just going to have Maria add, so the CC Polymers plant, by contrast, does not have jet diffusion.
That's
Right,
correct.
that one just has a pipe. Estevan knows, he was at the Water Development Board, I think, when it was built, but that one just dumps a pipe right into the floor of
right.
the bay or the
That's
ship
right.
channel. So knowing that and knowing technology, the jet diffusion is kind of elevated into the water body, right? It's not like on the, is that correct? That it's elevated it's kind of,
The jet diffusion will be underwater,
Right.
approximately 32 feet inside the navigational channel. So it will be dispersed inside the water.
Right.
One of the reasons why CC Polymers has not made the list for one of our sites is because they do have an open discharge, and that water would naturally float down as it's not dispersed in the method that we would like to see it.
And that's why we needed to take our time with the modeling, and that's why maybe some people wanted us to move faster with the discharge modeling so we get to the permit, but we wanted to make sure that we were using the best technology and the best modeling possible so that we can get the angles right so we could have that mixing done correctly.
Is your modeling based on the current status of the CC Polymers plant, or is it based on
We
what the
do-
water quality is once that plant is up and running?
Currently, we use what is in the bay, so anything that is permitted, such as the CC Polymers plant, is taken into account in the modeling.
Okay, I would just want to make sure I understand that. So your model's based on the water salinity that CC Polymers would produce if it was active?
That's a question I'll have to get back to you. I'm not sure if it considers a salinity, but it does consider the amount of discharge that we'll be producing. And based on their recovery rates, I would imagine it's very similar to our discharge.
And would that water quality have any effect on the performance of this proposed site?
No.
No, because
No.
of the distance where that particular plant is. It's further down the channel and away from our site. And that's what goes back to why we chose, this became one of the preferred sites. We had to take all those considerations of where other discharges were made, where other facilities were, to get to the preferred sites. And that's why the Inner Harbor location at Nueces Bay is one of our preferred site, and La Quinta site. So we took all those factors into consideration.
Yes, so CC Polymers plant would not have any negative impacts on our production or intake or discharge.
Got it. Thank you.
Councilman Lerma?
Thank you, Mayor. Peter, I guess this question might go to you. The salinity that we have in our bays and estuaries and all that, don't we have to have certain water releases throughout the year because of the salinity? How is that going to affect our water releases in the future if we keep putting this brine or salinity inside our bays and estuaries? As this is occurring, it's my concern.
Right.
I mean, because, it is, we gripe about the water releases
Yeah.
every time when the salinity gets high.
Right.
So this has got to have an impact to it, and we will probably have to, when they test the waters, have to have more releases of water down the river into our harbor.
Yeah, the staff, I probably aren't suited to answer that, but I think those discharges are to help further upstream in the Nueces River. I don't think do y'all measure it down here?
No, that's exactly right. Peter's
Yeah,
right.
okay.
Those releases are to mimic what the impact of the Choke Canyon Reservoir and Lake Corpus Christi are on the natural flow of the Nueces River.
Yeah, it's just a
not-
river, Councilman, so by the time you get down to the ship channel, we're not monitoring, we're not releasing water from the Choke Canyon Dam to have any impact on the ship channel, one way or another. It's for the river up by Cal Island. So what Estefan was saying is before the dam was built, there was certain flow in the Nueces River,
Exactly.
and certain wildlife and
Yes.
fish could live. So we're trying to mimic that, that's a good word, with the release of water, so that same fish and other habitat can live with the dam system that was put in place back in the 50s.
That's exactly right.
Right.
And Amber Otting, Water Utilities, hello. It's important to note that we're not adding additional salt into the body of water. We're putting back in what we took out. So there's not an increase of salinity or discharge or an additional salt going back into that body of water. That's why we're dispersing it. So there won't be an increase overall of salinity in the bay because we're not adding on top of. What we take out, we're putting back in. Does that make sense? Okay, thank you.
Councilman Pusley.
Thank you, Mayor. So let me be sure I understand this. I think this is important. So the CC Polymers discharge, for which they received a TCEQ permit to operate, doesn't go to the standard that we're going to go to with our discharge.
That's correct.
And we're going above and beyond what CC Polymers did on theirs, and they did receive a permit as well.
That's correct.
Okay. I think that's important to note.
Yes.
Okay. And yeah, if we do this correctly, the water that goes into the bay or La Quinta Channel or wherever we end up is going to be fairly close to the 35 parts per thousand that we're taking out.
That's correct, yes.
Okay. Thank you.
And Council, I think it's important to note that because of the efforts that staff and Plummer and Associates, working with Freese and Nichols, has created this model, and the study that we're implementing, we have every right to sort of anticipate this becomes the new model for everybody to follow, because of the steps that we're taking, like Maria was describing. We think this is going to become the standard that everybody in this area, in the coastal bend area, if they want to do a permit or get a permit of like what we're working on right now, are going to have to meet or exceed these standards. So, all right, continue on, young lady.
Okay, thank you. And next slide, please. Okay, and now we move to the La Quinta site. This site, including potential pipeline easements, which are not delineated here for legal reasons, is approximately 46 acres. And the same environmental responsibility will be implemented for the intake, as I previously mentioned, with the screen wiring or mesh screen. Again, the critical dilutions that were established for the different zones around the discharge are based on the tolerances of the various native species throughout their different life stages that are found to be protective of their life. And the zone of initial dilution, or that small half circle, and you'll notice it's a lot smaller on this slide, you can hardly see it. That's because the size of this channel is a lot larger than the inner harbor. And so within that 50-foot half circle, at the edge of that zone, the dilutions that we found to be protective of aquatic life are 56%, and in the aquatic life mixing zone, the orange middle circle, it is 18%. You'll note these are the same numbers as I previously presented because it's the same native species that live in this area. And so what that means, in the zone of initial dilution, the small red circle, in that zone, no more than 56% of the water should be effluent. And in the aquatic life mixing zone, it should be no more than 18%. Again, these are the percentages that we found to be safe for the aquatic life in the area. The results from the modeling for a 20 MGD plant and 40% recovery, which is the same as Inner Harbor, to compare apples to apples, the dilutions at those zones in the smaller red circle, at the edge of that zone, the dilutions will be at 10.8%. And on the aquatic life mixing zone, it will be 7.7%. Again, these exceed those percentages that we established to be safe. The modeling shows that we will be in a very good shape using our dispersion technologies. And so all the other recovery rates that we looked at for La Quinta, we looked at 20, 30, and 40 at the different recovery rates, 40 and 50%. They all fell well below those percentages that we established. And if you look at in the booklet that you have, the conclusions there show all the different scenarios that were modeled that meet all of these regulations that we have set on ourselves. Just to summarize is that all of these things that we looked at that are protective of aquatic life and our discharges will have negligible impact on the bays and estuaries and the residing life that lives there. And I just want to preface that it took time to do our due diligence, that we are not doing the bare minimum, and that we need to implement this project in an environmentally sustainable manner.
Okay, very good. Can we go
Wonderful.
back to the previous slide? So, thank you, Maria. Very well done. And she's going to be talking about some other things in the actual bay itself here in just a minute. But I do want to refer back to this slide and look at the approximate distances. I think this is critically important. So you have your red zone there, your ZID zone, which is where the discharge is going to be, where the diffusing is going to take place, the jet diffusion is going to take place. But we included these approximate distances so you could get a feel of how far away critical sensitive areas are away from the discharge site on the Inner Harbor and the La Quinta site. And we're literally talking miles away. We have full dissipation on the site within 200 feet of the diffusers, one direction or another. 200 feet. Is that right? No, not 200 feet, 200 yards, 200 feet.
100 feet.
So by the time it gets to that point on the little orange rainbow that you see there, it's completely dissipated and there is no impact. So we just want to make that clear because there's a lot of concern about the salt traveling. And so what we're saying is no, it doesn't happen with the technology that we're putting in place with jet diffusion. It suspends the solid and then with the tidal wave or with the velocity in the stream, it moves on. Completely ambient outside that 200-foot zone, which means the negligible impact to the water body and to the aquatic habitat. Next slide, Amber. And so you can also see it on this one on the La Quinta site. We did the same thing. We tried to come up with some distances that would have meaning, that you could all sort of look at this and kind of get a feel for it. And that's why we included that in that one. Okay, next slide. Unless you have any questions. Questions? All right.
Yes, and again, these maps are to scale, and again, the reason why it looks so much further in the La Quinta site is because that is a larger water body. Okay. And then here in this slide, I'll talk a little bit about the salinity levels in Corpus Christi Bay. As Councilmember Hernandez mentioned earlier, that the salinity in Corpus Christi Bay is very well studied. There is decades of salinity information, historical salinity information that TCEQ monitors. We have information back from the 1980s. And with this data, we consider the upper and lower limits of the salinity when running this model. So everything was looked at, the upper and lower, to make sure it's sustainable regardless of the salinity in the bay. We want to make sure that our projects are sustainable and that we will have running desal plants at all times. And then using this data, again, the modeling concludes that with our dispersion technologies, we will achieve all the critical dilutions that I mentioned previously. And I'll walk through this a little bit. So this graph here shows the the lower and higher limits of the salinity in the bay. That blue line that you see there, that is the average ambient salinity, which is approximately 32 parts per thousand. And then that purple line shows the salinity at the edge of the small circle, red circle, that's on the left. And the salinity at that time, it will be approximately 42 parts per thousand, and that is only 50 feet from the area. So 50 feet from our discharge point, we will be at 42 parts per thousand. Our ambient salinity is 32. And to put it into perspective, 50 feet is about half the distance from home plate to first base at the Whataburger field. And the salinity in the orange circle, the middle one, which is 200 feet distance from the discharge area, the salinity at the edge of that zone will be at 35 parts per thousand, and that's already less than 10% different than the ambient salinity. Once you get to that larger orange circle, as Mr. Murphy mentioned, we will be complete ambient salinity at that point. This is pretty much what I have. Now I'm sure you're probably wondering about cumulative effects over the long term of this plant running. So the modeling showed that no significant impact on salinity from the discharges for both these plants. So the model shows, assuming that we're running both of these plants full capacity, 30 at Inner Harbor and 40 at La Quinta, that for the life of the plants, it could be 50 years and beyond, up until it reaches equilibrium, it was observed that there would be a 0.3 parts per thousand increase in the overall average salinity in the bay. And this is less than a 1% change in the overall salinity, and based on the World Health Organization, a 10% increment above ambient salinity is still a conservative measure for the aquatic life. Does anybody have any questions? That's all I have.
Maria, I do. So roughly, 90 days ago when it was, we had our retreat, we had brought up the arsenic in the water.
Mm-hmm.
And I don't recall if that was, well, I guess this would be the time to address it regardless.
Yes,
So
so-
how would we prevent that?
So let me go to the next slide and I'll answer that
Okay.
question.
Wonderful.
I had one more slide, I'm sorry.
Sure. I thought you were done. Sorry.
Okay, so on the next slide, okay, what will be put back into the bay? Not only did we use the recorded data, but as I mentioned previously, we conducted individual water quality sampling at both sites. The water quality results indicate that there are no constituents of concern that would impede taking the water for our desal process. We collected over 12 months of cumulative sampling data, and we found no elevated levels of any of the heavy metals, such as lead, zinc, or arsenic, among others that were found in the water. And in your packet, there is a water quality section that graphically shows what was found for those constituents. Once the water is treated, all the solids that are removed will be dried and sent off to a landfill. So any of those constituents that were removed will not be returning back into the water. The only things that will be going back into the water will be salt and water. And these two ingredients will be then dispersed through the jet diffusion process. And again, it will just be the salt and the water at this time when it's being returned back to the bay. And along with the salt and water, actually, through the jet diffusion process, there will be a significant amount of dissolved oxygen whenever you disperse.
Right, thank you. Mr. Hernandez?
Yes, there are the port is actually getting 2 other permits, right? One at Harbor Island, the second, another one at La Quinta. Considering that the Harbor Island is close to the entrance, the jetty's going out, would you have the same impact on salinity levels?
The model that we ran, or the inputs for the model, did not include the Inner Harbor because it's not currently an existing permit.
You mean
for
Harbor Island?
For Harbor Island, right. They haven't issued that permit, so because of that, I don't believe it was considered in our modeling, and we have not studied the effects that.
So am I under the understanding that you don't have to take into consideration other permits or permit applications when you're doing your modeling?
No,
Is
we
that-
do, we do. But the port's application has not been granted. Everything else that has been granted was taken into account in the modeling.
And one thing with the ports
Well,
application.
Our permits haven't been granted, right?
Right,
So
but-
are they not taking ours into, our permit
No,
requests into modeling?
this modeling is modeling that we conducted to ensure that our dilutions would be appropriate for the aquatic life for our projects.
Okay. Thank you.
One more question, I think, Councilman Pusley?
Thank you, Mayor. So I looked at the numbers for the Carlsbad desal plant in California, which is the most environmentally conscious place on the face of the earth. And it looks like our numbers are going to be a little better than the numbers that they permitted there.
That's right.
That's right.
Yeah.
And we took those into consideration. I mean, we used more than 200 different references, scientific references, to do all this science that goes in the back end so that we can have these permits, that when we go to the TCEQ, we go with a good, solid model, solid application that takes into consideration going above and beyond. Using real data that was gathered at these locations. TCEQ does allow you to take assumptions in your applications. We didn't want to do that. We wanted to know what was actually happening. And yes, that took a little longer. That took 6 months to gather information on water quality, another 6 months to gather information on velocities. And so that's what the city council and what the city has done to make sure that the applications are solid.
Right. Yeah, well, I just think it's important to note that our numbers are going to be better than what was permitted at the Carlsbad.
And that goes back to my original statement. We think we're setting the bar for, good or bad, good for us, maybe bad for others, but we think we're setting the standard for people to follow, for companies and municipalities to follow if they want to do something similar to what we're doing. I think it's important to note. And it's good to be in that position. We want to be in that position. Okay. You ready?
All right, ready.
All right, so,
Yes, sir.
going into this next slide, Amber. Councilman Hernandez, this is where we get into, obviously, the Mary Road pipeline, and because there are issues, there are not issues, but there are questions about, is this the best use or the best use of funding to go after desal water when the Mary Road pipeline is there, and is it running at full capacity, and can we put water in there? So we wanted to talk about how we manage and maintain that pipeline. I think it's critical for council to understand that as we move this forward, and why desal is still on the forefront of the best option. So, Gabe?
All right, good afternoon again. So the Mary Roads pipeline brings water from Lake Texana and the Lavaca Navidad River Basin near Edna, Texas, and also the lower Colorado River near Bay City. The city has a contract for water with the Lavaca Navidad River Authority, or LNRA, and we also have water rights from the lower Colorado River. Next slide. All right, so we routinely pull 46 million gallons per day from the Mary Roads pipeline. For 1 month this year, we actually were able to pull 61 million gallons per day from the Mary Roads pipeline. And that was due to interruptible water being available from Lake Texana. When we have heavy rainfall in that area, we actually have more water available in our contract. And so with that, we were able to pull more from Mary Roads pipeline, 61 million gallons per day for a full month. So we have a 5-year plan for improvements on the Mary Roads pipeline, and it's in the capital improvement plan. And that's over $9 million is budgeted there. That'll give us the opportunity to pull the full amount of 70 million gallons per day through the Mary Roads pipeline. And one additional option that's been mentioned for water is the groundwater from Evangeline. And so for Evangeline groundwater to be added to the Mary Roads pipeline, it must be added below the San Patricio Municipal Water District diversion point. And so this groundwater would require reverse osmosis treatment to remove chlorides and to total dissolved solids. Next slide.
Gabe, can you stay on that slide real quick?
Sure.
So the picture in the middle is a good visual. So you can see the red line is the maximum amount of water we have water rights for in that picture. which would be 70 MGDs a day, right? That's our maximum permitted pull capacity. Today, we're at 66%, so the difference, 24 MGDs that we're not pulling, right, from those water sources. And what Gabe is saying is we want to do that, and there is a plan to take the maximum amount. It's going to take an investment of $9.1 million that's programmed in the budget that we'll talk to you about next week and when we have the work session. We need better pumps, new storage tanks, and a few other things to be able to pull that maximum amount efficiently. And so that's in the plan. And remember, back to today's work session, the question of the firm yield and when we run out of water, that assumption assumed that we're taking the full amount. So we need to get to that full amount of 70 MGDs from the Mary Rose pipeline. We just need to put a little bit more dollars, about $9 million, into the system to be able to pull it all. Right, so there's a small, you can see in the graph, the distance between the red line and the blue line is what's not coming in from those two water sources. But the staff, the utility staff knows that, and this has been in the works, that we need to get the rest of that. We're permitted to get it. It's a pretty decent price point, and we just need to invest a little bit more in the system to be able to do that.
Thank you, Peter.
All right, so looking at balancing our water quality, so the optimal blend of our source water is 50% Nueces River water and 50% water from Mary Roads pipeline. And broken down even further, it is important to utilize 50% Lake Texana versus 50% Colorado River within the Mary Roads pipeline. And so the optimal blend allows for our water treatment chemicals to be used efficiently, and it also allows our contracted water from Lake Texana and our water rights on the Colorado River to be utilized as well. The optimal blend of our source water, however, will change based on issues that occur at each of our four sources, such as a drought or heavy rainfall that occurs in the sources. Next slide. Okay, so looking at operations and maintenance and a comparison, here's a good comparison on the operations and maintenance of a seawater desalination plant compared to the O.N. Stevens water treatment plant. And so the equipment at a new seawater desalination plant will have a warranty period. We're thinking a 5 or 10 year warranty period time frame that goes along with it when it's started up. The membranes in particular, they're going to require maintenance cleaning every 3 to 6 months, and every 7 years they must actually be replaced. We're expecting to have the builder of the desalination plant work alongside us, the city operators, for a period of time after the desal plant is built. And are there any questions?
I'm sorry, can I point out one more thing? So if we look at the side-by-side comparison today in our treatment of surface water, it takes us 60 employees to do that, right? It's a labor-intense production, 60 employees. The desalination plant is a lot less, right? 16 additional staff persons or 16 equivalents. So it includes a lot of the technology or the processing that we do at Owen Stevens, and then it has one final step of the reverse osmosis. But you can see it's a much smaller staff complement, whether we do it or a private company does it. And I wanted to point that out to bring to our attention. It's not from a staffing standpoint, it's not a monumental project to run and operate every day. 16 employees compared to what we have every day at Owen Stevens, which is 60. Right, so we're in the labor business right now.
Yeah, so the beauty behind desalination is not the complexity of the system, it's the simplicity of the system. And in a conversation that Peter and I were having the other day, it's not rocket science to run and maintain a desal plant. Rocket science is a 50-year-old water treatment plant that you're having to run with today's dollars with equipment that was built 50 years ago. That's rocket science. This, on the other hand, like Peter is saying, is a much simpler process just because of the technology available. So it does have to go through the water treatment process. The headworks of a desal plant is basically the water treatment plant that we have at O.N. Stevens. That's why I asked Gabe to put together this side-by-side analysis, because really the hard work for a desal plant is the headworks, which is the basic water treatment that Maria was referring to in answering Mayor Guajardo's question about arsenic. That all goes through the headworks of the water treatment plant like it does today. And all of that stuff is taken out. And so potable water will be put back into the harbor along with the salt. That's what the process is. So the difficult part is the upfront water treatment process. The reverse osmosis, the membrane technology is fairly simple, and the technology is they've made it so easy to use. You've got 4 people that per shift that are basically managing and watching how operations work at a plant. So it's critical to understand that.
I think we've got a couple questions. Councilman Smith?
Thank you. So Gabe, you were mentioning that we on there, so has staff made the decision that we are going to operate that plant? And we've exempted out the design, build, operate long-term?
No.
No, not yet. We have not made that decision just yet. That was a good example, though, that if the city were to operate it, we would have the builder alongside us there for a period of time.
Now that's an example and not necessarily.
An example,
Okay.
of course.
Thank
Not
you
set
for
in
pointing
stone
that
yet.
out.
I think, Mike, you made a good comment about the headworks, that is, you look at the Tampa Bay plant, the litigation and the issues they had with that was the feed. And a desal plant is simple to operate, but they're very brittle. If that feed water goes in there and it isn't making the water quality, it's not like running Owen Stevens where we have a lot more flexibility. You foul those membranes and you're toast. And I think we need to look at Tampa and some of these, running a desal plant because of that water quality, that head water quality is, you got to be on your toes on there. It can be organic, it can be other things, and that's what happened in Tampa. They had a lot of organic problems, but you look at Carlsbad and you go out there and they're shut down for some reason or another, and why? Because of that initial feed water. But you have to run at a much higher ability than you do in a traditional plant with it, because that feed water has to be so pure going into those RO membranes so they're fouled.
Exactly. Yeah, and appreciate that. But the example was just me asking Gabe. I said, just to give a side-by-side comparison, what does it take to operate your plant versus a desal plant? Now, that does not mean at all that we've made any presumption of how it's going to operate, who's going to operate, or whatever. We were just trying to give a side-by-side comparison on that cost analysis. But yeah, the headworks is the key here. Desal, I mean, the critical piece of desal is getting that clean water into the reverse osmosis side. We all know that, and so that's critical. But we're used to it. We do it every day. We do it with, like I'm saying, sort of jokingly saying it, but the rocket science is operating a 50-year-old plant, not a brand new plant. But it's not to say that it doesn't come without its challenges. So that brings us to the end of our presentation. And so we want to go to the last slide here, and this is the critical slide.
Mr. Murphy, I'm sorry, I'm going to
Yes,
interrupt you. We have one more question.
Oh, okay.
Councilman
I'm sorry.
Pessa.
Yeah, Mike, I want to go back to the slide with the picture of former Mary Rhodes,
Okay.
Mayor Mary Rhodes in
There you
it. I'm sure she would be tickled at that. I have to ask this, okay? We're going to have to spend a little over $9 million to bring Mary Rhodes up to the point where we can use it at its full capacity. Now, when I read the Mary Rhodes standard spec sheets, I've ascertained you could run it at 75 mgd a day, but 70 is pretty close. The fact of the matter is we have a significant amount of water that we're not pushing through the Mary Rhodes pipeline that we are paying the rights for. So how long, and I know none of y'all are responsible, y'all weren't here, but how long has this been a problem? Has it been a problem since the Mary Rhodes pipeline was built? Or did this just occur in the last 10 years or 5 years? Or what caused us to get to the point where we can only use this pipeline at a little less than 50% capacity?
It's a fair question.
Right, so we can pull 2/3 of the capacity at this point. And actually, in the month of June, we were able to pull 61 million gallons a day out of the 70 possible for our water rights. But yes, so 4 years ago, 2017 is when we started utilizing the Colorado River there in the Mary Rhodes pipeline. And so we figured out the correct blend and the balance of what's needed. And so the goal right now is to utilize half of the Colorado River water Because our cheapest water is our reservoirs that we have on the Nueces. So Lake Corpus Christi, Choke Canyon, that's our best bang for our buck in terms of source water. It's about $2 per 1,000 gallons, and that's all the way through delivery.
Sure.
But we want to utilize all of our sources, and so with the current demands now, the way it plays out is half from Nueces River, half from Mary Roads Pipeline. And like I said, so on a routine day, 2/3 of the capacity is being used in the pipeline. In order to get us up all the way to the 70 million gallons per day, we have to do this, our capital improvement plan and the improvements there. And also the demand has to be there. Because remember the blend, the optimal blend is 50% Mary Roads, 50% Nueces. So if we're doing 70 million from the Mary Roads pipeline, then conceivably we would need about 70 million from Nueces. And we're not seeing that high of a demand just yet in the
Okay.
system. But we're going to be ready for it.
But
That's what the capital plan will
But
get
my
us.
question is, if we're gonna have to spend $9 million, there is some mechanical issue that exists that keeps us from doing
And I
that.
think,
Right,
I
yes,
think
sir, there
Daniel
is.
can talk about the engineering, that
Yeah.
mechanical issue that you're referring to.
Melrose Phase 1 was built in 1998. Since then, I think after that, the city conducted measurement and the assessment. We found, actually, Melrose Phase 1 consists of 3 sections. The first section is from the Lake Texana to the Bloomington pump station, then from Bloomington pump station to the Woodsburg pump station, then from Woodsburg to the Owen Stevens. We conducted a condition assessment. We found that the first section, there were high friction loss. So it means we cannot reach the regional design capacity. So,
Is there a cavitation issue, or?
I cannot say what kind of situation. What we know is the engineer conducted assessment. The friction factor is higher than what original design.
Okay, so your pumps you designed for that aren't able to pump?
For example, if originally we assumed that we can pump like 100 mgd, but during the real testing, we found about like more than 10% reduction. We only can pump like 90 mgd. Then think about the 3 sections. Another 2 sections maybe a less reduction. But the first section, that's the section 1 from the Lake Texana to the Woodsburg to Bloomington is the higher reduction. So that is like a hydraulical constraint. So we cannot fully make use of that.
So you're losing capacity at each section?
Yes.
So by the time you get to the treatment plant, you've lost north of 30% of the capacity of the pipeline?
Yes. So at that time, so when we do the Melrose Phase 2, then the engineer recommended several solutions from short-term, mid-term, and long-term. Right now, it's the mid-term solution is to recommended us to do some assessment again for the. So since 1998 to today, more than 30 years, we need to do the assessment again for the Melrose Phase 1, Section 1, Section 2, Section 3 to do assessment. Then recommended us to add storage tank in the Bloomington pump station and the Woodsburg pump station. Probably then we also to replace some pumps. That's why.
So this problem has existed since the pipeline was built?
Yes.
Okay.
But this normal. I cannot say the design is at the beginning is normal, but during the pipe over the years they were aged, so the capacity will decreasing. That's a natural phenomenon. This is why we need to do maintenance and in the future make improvement for the Melrose Phase 1.
Okay. Well, Mike, the point here is we have to be able to tell the taxpayers that the justification for building a desal plant is true, and that we are able to use the capacity of our existing pipeline, the Mary Roads pipeline system, which they've already paid $150 million for.
Correct.
Before we can go forward. So we have to be able to justify those two things.
No, I agree 100%. And so what Daniel is referring to, for those who didn't catch some of that, the coefficient of friction is a real factor. Those of you who are in the pipeline business and construction knows how detrimental that can be to a water line and a sewer line for that matter. Yeah. And in the case of really turbid water, difficult to treat kind of water, the coefficient of friction probably takes its toll quicker than it would if it was just regular lake water. Let's
No,
say.
I understand that, you know.
Yeah,
and
so it's a real thing.
The
So we've got
business
to
I
do
was
that.
in, we had really smart people who calculated that stuff all the time.
Yeah, so it's a real physics kind of an issue, and you see tuberculin growth in water lines all across the city, which is one of the reasons that we're replacing so many water lines across the city right now. This is just much larger. It's a much larger version of that. So I agree 100% that we've got to be able to explain that. That's why I wanted to include this conversation as part of the presentation. I know it kind of gets a little wonky in talking about that, but I think it's important to know that we're trying to use every source of water to its maximum capacity. Yeah. Now, let's just say we could run the Mary Road pipeline at 100% capacity. We also have to remember that it's getting close to 25 years old, which is middle age for a pipeline, right? If the pipeline has a lifespan of 50 years. So you have to start thinking about that when you're trying to push a lot of water through that. And I think we've already seen issues of trying to over-pressurize, excess capacity, trying to move too much water too quickly through that pipeline, the results that we get on an older pipeline.
I understand that, but we just need to have all of
Yes,
those,
sir.
those quivers in our, back pocket
No,
whenever those questions come up, and be sure we understand what's going on, that we can explain that to the public. So Peter, is that $9 million going to be put in our next budget cycle, or?
I believe is it in the first year plan or the?
It's spread out over the next 3 years.
Yeah, you'll see it. So next week, Councilman, when we present the capital and operating budget, this will be in our capital improvement program for the next 3 years, the $9 million.
Okay.
It'll be spread over time. But more directly to answer your question, the impact to the rates, right, will be in there. Also in the budget, though, this Mary Roads pipeline is quite the asset, and the city needs to applaud itself for building it back years ago. But as Mr. Murphy said, it is aging, so we're going to recommend additional staff to monitor that 100-plus pipeline. Right now, one or two does it, and that's not enough. So we're going to kind of break it up into quadrants for constant monitoring. We're also putting in more cathodic protection to minimize rust and disintegration of the material. And so there's a pretty good investment that we're putting into the pipeline to protect the investment of the ratepayer and make sure it has a pretty good lifespan. So you'll see that also next Tuesday, and then in the utilities workshop following.
Okay, excellent.
Yes,
Thank
sir.
you very much. Thank you, Mayor.
Councilman Smith.
Thank you. So just to kind of clarify, so Steve, is our firm yield calculation based on the actual capacity of the Mary Roads or the design capacity?
It's based upon the contract and the permit capacity.
Okay, which the design, but under the actual capacity, we can't take that much?
Yes.
Okay, so to get to our firm yield calculation, we've got to bring Mary Roads up to that 70 MGD.
Yes.
Okay. Yeah, I appreciate it, thank you. And one thing I'd like to add on there, so the cost of the Mary Roads, it was mentioned at 150, wasn't Phase 2 about 177 million?
Phase 2 is 156 million for 42 miles of pipeline, and that was in 2016
And we have
dollars. And the first phase that goes to Lake Texana was around 116 million, and that was a 101 mile pipeline with two pump stations.
Okay, thanks.
Okay. All right, so we'll, thank you for listening to us today. So we're going to close with this last slide, which is sort of a timeline. So I've got it set up in 5 different steps here. This is 5 different steps. We're on step number 1. And so the goal of today's presentation was to identify a Phase 1 site and a Phase 2 site and authorize staff to move forward with negotiations on property acquisition of either the La Quinta site or the Inner Harbor site. That was our goal today. And working with the city attorney, we've already got and based on the direction, like Peter was saying, based on the council meeting back in 2019, we were given directions to move forward. And if you bear with me here. Okay, so the 75% trigger point was established. Staff recommendations from council were the two sites, the Inner Harbor site and the La Quinta site. The permitting process is already underway. We've got 4 pending permits with TCEQ right now. Financing is already set with the SWIFT funding. We've already set that up for the low interest loan of $222 million. And the phased approach is phase 1 or phase 2. So we've got to talk about the permits. We have every anticipation that they're going to be approved based on what you saw here today and the standard, the bar that we set for the permitting process, for our environmental impact. We feel we have every reason to believe that they're going to be approved. So now we have to go into the next step, which is property or right-of-way acquisition based on phase 1 or phase 2. Now, we've already met with property owners for the phase 1 Inner Harbor site, phase 2 Inner Harbor site, whatever you want to call it, and the La Quinta site, phase 1 or phase 2. We've already had initial negotiations and meetings with them. So the table is set. We just need to sit down probably in an executive session with council and go through that, but we've got to select the first phase 1 site before we can do that. That's where we are today. We're at that point.
Okay, and I've got a question, and we still have a couple questions also. So how much water will industrial users need in Sampat or consume once Steel Dynamics and Growth Ventures, all of that is 100% online?
I don't have that number. Does anybody? Somebody's back there puffing out a number, 25 million.
Aaron?
I'm not sure who that is.
That's Aaron. I mean, roughly. You don't.
Our take-or-pay contract's 15 MGD with Gulf Coast Joint Ventures and 5 MGD with Steel Dynamics. So that's what we're contracted for under the.
So into all industrial users in Sampat, it's safe to say, what? No.
Well, we've got Brian
answering
Williams here, and I actually talked to Brian a little bit before this meeting. I said, we may call you up to the
Sure.
podium. So does everybody know Brian Williams, General Manager at San Patricio County Water? So Brian?
Sure.
Welcome. Welcome. Yes, sir.
Brian Williams, I'm General Manager of San Patricio Municipal Water District, resident of San Patricio County. As far as our industrial users go, right now we're delivering about 11 million gallons a day to the industrial customers before Gulf Coast Growth Ventures came online, before SDI came online. Right now, we're continuing to deliver about that 11 million gallons a day. Gulf Coast Growth Ventures is in the testing phase, so they're not taking their full amount yet, but they are contracted to take up to 25 million gallons a day, 15 million gallons a day take or pay. SDI is still in the testing phase. They have a 50 million gallon pond, so they filled it up before the rains came, and they haven't had to fill it up since. They're currently not even taking any water while they're coming up. I don't know if that answers the question, or.
I mean, not really. Once it's all.
Okay.
Sort of, but what would your estimate be? When they are 100%, they are going to take, I realize there's kind of two answers. They're going to take what they take, and then they can take up to, right? What the agreement says. But what would you say just roughly, once they're full blown?
I would anticipate 11 plus 25, so 36 million gallons a day. Does that include Exxon or not? Yes. Yes. 20 for Exxon, I guess on a day-to-day basis, 5 for SDI, since it's full take or pay, and then about the 11 million gallons a day that we're doing on top of that.
Right, that answers it, thank you.
Okay.
Thank you, Brian.
Thank you. So, Mr. Murphy, I would say, based on one of the points that was brought up in regards to going through Sandpat Water District versus pipeline, right? And this is just a scenario, correct? That the councilman brought up. While you're looking into that option, I'm curious as to, let's say that option was brought forth and saying we can route this water to, we can route it out through, right, Sandpat.
It's
Then-
my understanding that the ownership of that pipeline, I'm sorry, can you hear me? The ownership of that pipeline is not the city's. That's not our pipeline. That
No, I
pipeline
understand.
belongs to Exxon. So there will have to be a conversation that will happen there.
Right. So let's just say we were
Okay.
looking at that route.
Yes, ma'am.
Then we should be looking, I would think, at what this would at least look like in terms of one plant that is expandable versus the investment of two. Because we're talking cost, and at the end of the day, the cost is what matters. And none of us want to sit up here and approve what we're only focusing on $222.4 million, million dollars, right?
Yes, ma'am.
We don't know that it's 222.4. We don't know that. You told us that. We don't know that. That is
That's the-
priority, I would say, for
Yeah. That's the
everyone.
engineer's estimate until we bid the project
Right, until
out.
we
That's-
bid, right.
That's it.
Right. So while you're looking at this piece of it, what if, I would like to know what if, and give us some information around one plant would look like.
Okay.
Because right now, 222.4, but what's the plus? The plus is my 16-year-old is going to deal with it
Yeah.
later. So
Well,
what
it's
is
actually
the-
243. You're thinking of the Inner Harbor site.
Yeah.
Yeah, so it's actually at 243 plus.
Sure.
What that plus is. So you're asking us to look at what that plus would be in conversations with Exxon, us using that pipe to, but I understand the diversion question, so I
Right,
get
and just
that.
looking at what was brought up earlier.
Yeah.
Look at what that would be in
Yeah.
terms of the one plant versus two phases.
Okay.
Does that make sense?
It does, it makes sense.
Okay,
Yeah.
okay.
No, we'll do that. But the goal still is trying to get council to the point, because
Right.
if you go back to what was said during the retreat, start moving this project forward, is still to get council into a conversation about which site to select. And I know that's where you're going, that's what you're looking at.
It
to-
is,
To have a
and
better idea of that.
Mr. Murphy and your team, you should know that no one is interested in reversing and rewinding, and let's just start a whole new task force. You know, I know that's what you are, you're praying is not going to happen. You know, there was a team put together, there was a reason, and
Yes.
when we came in 16, it was towards, I guess it was the end of their discussions, and we don't want to undo everything, but this is
Okay.
the biggest decision that this council's going to make or continue to, right? And so into, the next phase of the council members here. So it's just extremely important. So I appreciate all of your due diligence. I really do, and I know they do too. But we're going to keep asking these questions, and we appreciate you coming back. I've got 3 things you're coming back with, and so I agree, we've got to keep moving forward. And so we'll do that as a team. Councilman Pusley.
Yeah, I just want to say real quick, Mike, I think this was really good. This is, the next step in the phase, and I agree with the mayor. We don't want to start over again, but, we have some options here. Permitting is most important right now, and we need to move that bar forward. I appreciate all the work that all of you have done, and especially for keeping the environmental concerns in mind and making sure we're doing the right thing. And this is great. And the community, I think, is going to feel a lot better about the fact that we are moving this bar forward. And then when we get the permits in hand, then this council can make a decision about which way we want to go at that point. But, and Mayor, being as that Councilman Martinez and I worked together to save $100 million.
Yes, thank you
I
for
think
that.
pay raises in due.
You know what?
So,
I made note of that.
A bonus or something.
Yeah, something.
Thank you very much.
Yes, thank you. I appreciate that. And it's there's a lot of work. I mean, nobody wants to hear how hard other people are working. But in the last 8 weeks, I can tell you, we've probably met this group 20, 25, 30 times. They're sick of looking at me while we're having lunch together. So, but I do want to express my appreciation for the hard work that Amber and her team and our scientists and engineers have come up with. I think we need to be extremely proud of the caliber of employees that we have working for us. I think it says a lot.
Yes.
And so thank you all.
It does. Everyone did a wonderful job. I have to just shout out to Maria, though, because environmental, that's a big one, and that's extremely sensitive. So thank you for that work. Councilman Hernandez.
Yes, thank you, Mayor. To me, this still gets down to a financial decision, and we can't look at desal in isolation. We have a lot of other things that we have to concern with. Obviously, it all impacts our rates. The EPA consent agreement that requires us to spend $725 million over the next 15 years to repair all that. And obviously, we want to spend a Friday visiting wastewater lift stations.
I hope you've
okay?
taken another look at that. But no,
Well, you understand
Yes, sir.
the
I
severity of it.
I do.
We also have an issue with the TCEQ and to improve the water flow and pressure within our system, and we have lots of issues there, which is almost as expensive in cost as what our concern with wastewater is. There's a lot. If you look at our CAP, there's a lot involved in there as well.
sir.
That is significant amount of money. And you add $222 million on top of that, regardless of our debt capacity, what's coming off, we must also look at the best financial solutions regardless, and also look at really what the cost per 1,000 gallons is, regardless of where it comes from, regardless of how it does it, because what you're showing us here is the options for what we're pursuing, right? Design, build, operate, or whatever that turns out to be.
Yes, sir.
Whatever
option is
that you're
clearly
showing
still
us
on the table.
the numbers for that.
Yeah.
You're not giving us any information on other options. There's 2 other permits that are going out, well, 4 technically, if you're looking at what the port's doing, that may have other options. You know, I think what the mayor was saying with the situation with the pipeline that Exxon, Savic or Growth Ventures is putting forward, that gives us more options on that side of on that side as well, on the San Patricio side. So ultimately, what this really needs to look at, what we really need to look at, is the long-term financial cost, right? Cost per 1,000 gallons over a long period of time, you know, lifespan of what we're looking at, right? Similar to what you would look at with Mary Road's pipeline. But when are you going to give us that information? I mean, when are we going to be able to look at those other options?
Yep.
Is what I'm asking. I mean, you're asking us to go forward with your options, and I can understand it. I don't think we need to purchase property. We could put an option down on a particular property specifically, so we're not tied to that. We don't end up buying a piece of property that we may not use. Okay, so there's options there, but ultimately, it's a financial cost.
Yeah.
Because I can tell you, nobody in Corpus Christi really cares where the desal plant is. Heck, you probably ask half of them, they don't know where Owen Stevens is. Okay, that's not the concern, but what the concern is what they pay in a monthly bill, right? They see that, it shows up at their doorstep, in their mailbox. Right. And so that's what ultimately we have to make sure that we're cognizant of, because that's what they're gonna look at on a regular basis. And I wanna make sure that there's been a lot of neglect, and nobody here is responsible for that. I'm not blaming anybody, but there's a lot of neglect. We didn't do the preventive maintenance we needed to, and we're in the situation we're in now, and we have that financial obligation that we agreed to pay for. So I can't stress it enough. We got to have options. It can't just be us taking all the responsibility and absorbing it all and taking all the risk ourselves. There's got to be some other options as well, and I'd like to see those costs.
Okay. Okay.
Last thing I want to ask for, and I understand our partner here was San Patricio Municipal Water Supply. They did a study on alternative water supply with Corolla. I was wondering, did they share that with us?
Are you-
This has been kind of taken, I guess, through the legal process. It was requested of us by an attorney's office, went to the Attorney General's office. He did a redaction on it, so I'm not sure if they have the redacted copy or not, but I'll be glad to provide a redacted copy.
Okay. If that's all you can provide us, that's,
According to the Attorney General, that's my understanding.
okay. I'm assuming that you expect redacted studies from us to be provided to you as well?
I haven't asked.
Okay. All right, thank you very much. And I want to really stress the financial aspect of this.
Okay.
Cost per 1,000 gallons over a long period of time. And it can't just be what we're doing here. This is not enough to make a $222 million decision in light of all the other obligations we have within our utilities.
Thank you.
Thank you.
Councilman Smith?
Thank you. And to follow up on Councilman Hernandez's point, I think all of us, that the cost of water is our number one issue. But I think what he was driving at is we have two things he was talking about. One is cost, what is the cost of the ratepayers going to be, and the other is debt capacity. These are two independent, so that, if we got to improve our distribution system, we have to improve our distribution. So when we look at it, they're actually two different items. One is the cost. We can go to Poseidon and get $10 a thousand water. They'll do it all day long, or some of the other ones on there. So I think we need to be very careful when we look at that. Debt capacity is one issue, bottom dollar cost is another. Okay. So, we can go to a third party, and the contracts are out there. There's 14,000 desal plants in this world, and a lot of those are privately operated, and there's plenty of research that we can look at to see what costs that they are. And, we've got, like I said, the Carlsbad plant in California is a great example of that, and we also have Vista Ridge in San Antonio. This was a P3, and they're $585 a thousand to the distribution point. I think Carlsbad right now is up to $10 a thousand to the distribution point. But those are the things we need to look at.
Okay.
Okay, I think that wraps it up.
Yes, thank you all very much. And we'll pull those numbers together very quickly so that we can keep this process moving forward. I know I've said that enough times.
And the other information. One numbers, but yeah.
Real quickly, I appreciate all the comments, but I just want to say, this community expects this council to come up with a solution for our long-term water issues. And we got to keep that process moving forward. And this is the first step. This is not the final solution. We're going to look at the cost. I'm as concerned about cost as anybody, but we got to continue to move this process forward. So that's important.
Thank you, Mr. Murphy. Thank you all.
Thank you very much.
Maria, thank you. Okay, there being no further business, this meeting's adjourned.
The CDC announces that the Pfizer vaccine is now approved for 12 to 15-year-olds. Corpus Christi parents and guardians can now take their child to the Health District Vaccination Clinic at La Palmera Mall or other pediatric clinics to get vaccinated. Local health experts say the child vaccine